Calculating molecular formula. We're going to calculate molecular formulas by doing the same steps we did to calculate empirical formulas with a couple extra steps. So if you have not watched the video for empirical formulas, please do so before looking at this video. You will see from this problem that I have some spots I organized it. You can organize this in whichever way you wish, but here I've provided you a way to organize this. What you will notice about this problem compared to the empirical formula problems is I also give you the molecular mass. Right here, 176 grams per mole. So you will have to be given the mass of the molecular formula. That term here could be molecular mass, molecular weight, formula weight. Any of those things mean the mass, the periodic table number of the molecular formula for which we're trying to solve for. So you can place that number down here where we find the box for molecular mass. Next, you will perform the 4 steps to calculate the empirical formula. Percent to mass, mass to mole, divided by small, multiply to whole. Remember, we always have to do the middle 2 steps, mass to mole, divided by small. But on some problems, you will skip the first step, percent to mass, and the final step, multiply to whole. In this case, we'll see what we need to do. Let's go ahead and begin. So we're going to say assume 100 grams because we do have to perform the first step, percent to mass, because we have everything in percentages. Remember when we say assume 100 grams, that means that then if I have a 100 gram sample, 40.92% would be 40.92 grams. So next step of the poem is mass to mole. So we take each of their masses and divide them by the periodic table number to get our moles. Then we're going to look at these and we're going to be divide by small. Remember, this is the third step, the second middle step, or the third step altogether. You cannot skip this step. So we're going to divide all 3 of these by the smallest of the 3. So I'm going to divide them all by 3.406 and get these ratios. I'm using sig figs here in my answer. Here then we're going to multiply all of them first by 2. If I multiply them all first by 2, I would get 2.00, 2.66, and 2.00. So I wouldn't be able to round these. Remember that before we even started about multiply to whole, we'd first have said, oh, I can't round this, because the rule has to be that these can be only rounded if there's a 0 or a 9 in the first decimal place. Because I have a 3 in my first decimal place, I'd have to multiply all 3 of these by 2, and then I would get that 2.00, 2.66, 2.00, which means I still could not round them because I would have 2.66. So then I'm going to go back to this start and multiply all of them by 3. If that didn't work, 4, and I'd keep going. In this case, we're going to be able to multiply them all by 3 and get 3.00, 3.99, and 3.00. So now we have a 0 or a 9 in the first decimal place for all of the parts. So now I can just round till whole. So I do that here. I got 3 carbons, 4 hydrogens, and 3 oxygens based on my multiply times 3 to get to whole. I can figure out the empirical mass, that is the periodic table number or the molar mass of C3H4O3. So that's 3 carbons, 4 hydrogens, and 3 oxygens. When I do that, I get 88.07. Now, to figure out the molecular formula, we have to do me. Here is what I mean by the me. We take M over E, my molecular mass over my empirical mass, 176 over my empirical mass, 188. Remember, you're given 176. You do all of this work to get the empirical formula, and then from the empirical formula, you can calculate the E, the empirical mass, and you're going to divide those 2 over, and then you're going to figure out your ratio, and you get, this is 1.998 or something like that, which would round to 2.00 sig figs. So that means that the molecular is twice as big as the empirical. Whatever you get for this me part, I'll call this you got to me it. When you me it, whatever your ratio is, that's the factor you multiply your empirical by to get to your molecular. So I will multiply all of these, each atom, by 2. So 2 times 3, 2 times 4, and 2 times 3. When I do that, I get C6H8O6. That completes the problem.